Day 9, more of 5.4, but instead of differentiating exponential functions, this time we're going to integrate them. So now we're reversing the process, antiderivatives. So the antiderivative of e to the u, du, is e to the u plus c. One of your favorites, I would guess. So I got three problems set up here. So first one, integral x e to the x squared. The only thing we know how to integrate is e to the u. So with that said, there's a really nice hint set up with problems like these. Because when you look at this, if you see an e in there and e's got a power on it, that power is probably going to be your u for your u substitution. So du would be 2x dx. The x dx in the problem is going to be half of my du. So what I really have now is I've got, let's see, so 1/2 of the integral of e raised to the u power du. That's the case. So what I've got, 1/2 e to the u plus c. What's u? 1/2 e to the x squared power plus c. And if you want to check that, you could take the derivative. Derivative of e to the x squared would be e to the x squared times 2x. The 2 and the 1/2 would cancel out, and that would leave us what we started with at the beginning of this problem. So there's your first step. Second one, here we are now. A little bit different setup. I can see that we've got a quantity. I see one term again, and it's got a square root in it, and the square root has multiple terms in it. So I'm kind of feeling like u has got to be what's inside that square root, the inside function. So then du would be negative e to the x times dx, and that's interesting because I've got an e to the x and a dx in the problem. So that e to the x and the dx that's in the problem is going to be the opposite of my du. So I'm going to have to throw in a negative to go along with my integral of my square root, and that square root is of now u with a du. So integrating u to the 1/2 power, add 1 to the power, divide by the new power. So negative, add 1 to the power would be u to the 3/2. Divide by the power would be the same as multiplying by 2/3. Don't forget your c. So negative 2/3 times the quantity 1 minus e to the x raised to the 3/2 power plus my c. So there's two of them. So second case is we've got an extra e to the x in there. So whenever your u has an e to the x in it, your du had better have an e to the x in it also. And then number 3, what we have going, I've got all kinds of terms. I've got multiple terms on the top. I've got multiple terms on the bottom. Tricky thing is going to be I'm going to have to be able to try to find my way around this thing. So I'm feeling like when in doubt, let's try u substitution. Is anybody's derivative in the problem? Some of our tricks. This is one of those that we might just have to try and see what happens. So I'm kind of feeling like right here, what if we try u being the denominator? Because maybe it's a natural log or something like that. So e to the x plus e to the negative x. People ask the question, why pick the denominator? Well, when was the last time you saw du on the bottom? You never see du on the bottom. You always see du on the top. So I kind of feel like let's try making u the bottom. So then du, let's see, derivative of e to the x would still be e to the x. Derivative of e to the negative x would be minus e to the negative x. And all of that would be multiplied by a dx after we separated our variables. And just like that, look at that. We've got the numerator is this quantity. So my e to the negative x minus e to the x minus e to the negative x, this thing is my numerator. My dx is already in the problem, which means I can rewrite this thing, and it looks like I don't even have to throw anything else in. I've got a u on the bottom, and I'm going to put a 1 up here on the top because the du accounts for everything else. So now can I integrate that thing? You bet I can. Whose derivative is 1 over u? Well, let's see. So how about natural log absolute value of my u plus my c, natural log absolute value e to the x minus e to the negative x plus my c. Now, you know we shouldn't leave negative exponents in there. So there is a solution, but I don't know that you're going to find that solution a lot of places. I think what's going to happen instead is they're probably going to take what's inside quantity, then they're probably going to change it. So if we go to change it, how about natural log absolute value e to the x minus 1 over e to the x plus my c. That's one way we could do it. But my bet is that in your solution manuals, in your multiple choice questions on your AP exam, those types of things, they're not going to have it in this form. They're probably going to change it. They're probably going to do common denominator. So if we do common denominator, we would multiply this first fraction by an e to the x over an e to the x. And if we did that, we would have, let's see, so let's take another route here. So natural log absolute value of e to the 2x, e to the x times another e to the x, minus 1 over e to the x. There's my common denominator. Again, nothing wrong with it. But you know what they're probably going to do is they're probably going to look at this and go, hey, if we did log rules, we could have natural log absolute value e to the 2x minus 1 minus natural log of absolute value of e to the x plus c. Now, e to the x is always positive, so that absolute value is not necessary. But what's going to happen with this term right here? They're going to take that x and they're going to make a coefficient out of it. You're going to have natural log of e. In your solution manual or on your standardized test, it's probably going to read this way. This is probably going to be your choice. Minus, put the x in front, natural log of e is going to be 1, minus an x plus a c. And what I wanted to do with this is I wanted to just get you ready that you may get the blue answer and feel good about it, and you're not wrong, but the standardized test answer might be red. So you've got to be able to use those log rules in order to be able to equate one with the other. So there's your integrating e to the x function.